Good morning, everyone. My name is Specialist Williams, and today I will be conducting a class on how to determine a grid azimuth on a map. Prior to beginning class, I would like to go over any safety hazards to ensure the safety of you all as well as myself. We are an inside environment, so any safety hazards could be anything as far as miscellaneous things are placed along the floor or any cords or anything of that nature. Please be on the lookout, be aware of your surroundings as to make sure that you all remain safe for the entirety of the class. Now, to determine a grid azimuth on a map, I will first read our conditions. Given a standard 1 by 50,000 scale military map, with two known points plotted on the map, a protractor, a straight edge, and a pencil. So just now I've read the materials that we will need for this class. We will need our military scale map, which is placed behind me here. We will then need two known points plotted on the map, which is also behind me here. A protractor, which is in my hand, straight edge, and a pencil. I will continue. The standards are to determine the grid azimuth in degrees from your location, point A to point B, within 1 degree. So, I will now read our performance steps. The direction from one point to another, either on the map or on the ground, is called an azimuth. Azimuths are given in degrees in a clockwise direction from north, and all azimuths taken from a map are grid azimuths. An azimuth in degrees can be any number up to 360, since a circle has 360 degrees. Due east is 90 degrees, due south is 180 degrees, due west is 270 degrees, and due north is 360 degrees or 0 degrees. So just now we've determined our north, south, east, and west along our maps. It is good to orient yourself with the map. It is the best thing to do so that you know what it is that you're reading, know what it is that you are looking at, know what it is that you are trying to achieve. So it is the best thing to do to orient yourself with the map, which is why I've just given you those degrees, due east being 90, due south being 180, due west being 270, and due north being 360. For finding your grid azimuth, we will always use due north. It gives you the full 360 degrees. That way your grid azimuth is as accurate as possible. There are no restraints whatsoever. I will continue. The most accurate way to determine an azimuth from a map is to use a protractor. The Army itself uses two types of protractors. For this sake, we will be using the square protractor, GTA 5x2x12. And it has two scales. The inner scale is a degree scale and the outer scale is the mil scale. So we will be using the inner scale. And just for demonstration purposes, excuse me, we have our protractor here. Our outer scale is literally what it means, our outer scale. And we will be using our inner scale to determine our grid azimuth. It not only gives us a more accurate depiction of what it is that we are trying to find, but it is also the degrees that we are going in. We are finding degrees, not mils, which is another reason why we'll be using our inner scale. All right, let's continue. Now I will discuss on how to use the protractor properly as another safety hazard to just ensure that you all are aware of what it is that you are needing to do. So when using the protractor, the first thing you will be doing is plotting 2 points on the map. So our points are already given to us. We have here point A, and we have here point B. So the first thing you are doing are plotting 2 points. Anywhere on the map, just take 2 points and name them points A and points B. From there, you will be using a straight edge, just making a straight line to connect those 2 points. So we've plotted points A and points B, and then you will be taking a straight edge and connecting those very 2 points to connect the two. So you are quite literally drawing a straight line between points A and point B, which are two known points on your map. So far, all we have done is found two known points on our map. We've named them points A and point B, and then we've connected them with a straight line. Next, you will then place the index of the protractor at the point where the azimuth line crosses one of the lines. So what that means is, now that you have plotted points A and point B, and you've connected them with a straight line, you will then take the protractor and place it to a point where the line crosses on the map. Whether that be vertically or horizontally, you will connect the line, you will connect your line using your protractor. So, as I've mentioned before, we are using our inner scale, so that is the inside. So as you begin to count your tick marks and determine your grid azimuth and everything of that nature, remember to use the inner scale of your protractor, which will give you degrees. You will also be using due north. So as I previously stated earlier, our degrees and how we needed to orient our map. As we find our grid azimuth, we will be using due north. It gives us a full 360 degrees, full range to find exactly what it is that we need to find along our map. So to do so, you will be using the 0 on the protractor. You will line up the 0 with the point on your map as to connect it to find your other point and determine that grid azimuth. So let me review that again for you. We have plotted points A and point B on our map. We then connected the two with a straight line. We are now at the step of finding the grid azimuth by using the inner scale on our protractor and aligning our 0 with one of the points on our map. So now, starting at point A and using our inner scale and the 0, we are lined up with our protractor and our map and our point to determine the grid azimuth. Each tick mark on your protractor will serve as a degree. And you will continue to count each tick mark until you reach your next point, and that is how you will determine your grid azimuth. It's just that simple. Alrighty, so from our point A to point B, our grid azimuth is 70 degrees. It is literally just that simple. Finding the grid azimuth literally takes about 3 minutes. Explaining it is a longer process than actually doing the act. Now that I have gone over in detail how to find the grid azimuth on a map, I will now give you all time to conduct this for yourselves. I have already given you a known 2 points on your map. All you will need to do is the following instructions that I've given you previously, which is using a straight edge, connect those 2 points, and then placing your protractor using the due north, which is the 0. You will then count each tick mark from one point to the other, and that will determine your grid azimuth within degrees. I will now give you about 5 minutes to do so. You need 3. I'll give you the extra 2 just for safety hazards and fun and anything of that nature. If you need any help, I will be walking around to help assess in any way possible. Please take your time now. Alrighty, so at this point, you all should be done. I have graded everyone's paper, and I am pleased to say that everyone here is trained and proficient in determining a grid azimuth on a map. Now that we have done so, we will also now police our area. We again are in an environment where there may be any tripping hazards due to cords or miscellaneous items on the floor. So just ensure that everything that you have with you, you police up. I have my protractor, I have my pencil, I have my map, everything within me as to ensure the safety of myself as well as you all. Now, we will also conduct an AAR. What we were supposed to do today was taking a 1 by 50,000 scale military map. We were to find our grid azimuth with two known points pointed on the map using a protractor, a straight edge, and a pencil. What we actually did was using a map, a protractor, a straight edge, and a pencil, we determined our grid azimuth. Now, at this time, are there any improvements? Thank you. Are there any sustains? Thank you. And are there any recommendations? Alrighty. At this time, this does conclude my briefing on how to determine a grid azimuth, using a protractor. I thank you all. You all have been trained. Have a great day.